Alright, so for this video, I'm going to be solving the equation 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. So, I'm going to be solving for x in this equation, as that is the only variable. And now for my solution. I'm going to start by rewriting my equation down here so I have more solving space. So my equation is 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. Now from here, I'm going to be using the property of exponents that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 8 to the power of x plus 9, and I can rewrite this as 8 to the power of x times 8 to the power of 9. And this is equal to 9 to the power of x plus 8, which I can also rewrite as 9 to the power of x times 9 to the power of 8. Now from here, I'm going to divide both sides by 9 to the power of x. So then for my right hand side, these two cancel out, and I get 8 to the power of x times 8 to the power of 9 over 9 to the power of x is equal to 9 to the power of 8. Now I'm going to divide both sides by 8 to the power of 9. So then these two cancel out, and I get 8 to the power of x over 9 to the power of x is equal to 9 to the power of 8 over 8 to the power of 9. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x over 9 to the power of x is equal to log of 9 to the power of 8 over 8 to the power of 9. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log 8 to the power of x over 9 to the power of x is going to equal log of 8 to the power of x minus log of 9 to the power of x. And I can use the same property of log 9 to the power of 8 over 8 to the power of 9 to make it equal to log 9 to the power of 8 minus log 8 to the power of 9. Now, another property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is the same thing as b times log a. In this case, I can use this property for all my terms over here. So to start, log 8 to the power of x, I can move this to the front, and I get x times log 8. Now I have this minus log 9 to the power of x, I can move x to the front, so I get x times log 9. And this is equal to log 9 to the power of 8. I can move 8 to the front, so I get 8 times log 9 minus log 8 to the power of 9. I can move 9 to the front, so I get 9 times log 8. Now, because both of these terms have x in them, I can simply factor out x. So I get x times log 8 minus log 9 is equal to 8 times log 9 minus 9 times log 8. Now, we obviously want to find the value of x, and the only way to do that is to get rid of this log 8 minus log 9 by dividing both sides by log 8 minus log 9. So then these two cancel out, and I get x is equal to 8 times log 9 minus 9 times log 8 over log 8 minus log 9. Now, log of 9, we can simplify this to log of 3 squared. And remember, if I have something in the form log a to the power of b, I can move b to the front. So I can move 2 to the front, and this is going to equal 2 times log 3. Now I can do the same thing for log 8. Log 8 is equal to log of 2 to the power of 3, and I can move 3 to the front, so I get this equal to 3 times log 2. So now from here, I get x is equal to 8 times 2 log 3 minus 9 times 3 log 2, and I have this all over 3 log 2 minus 2 log 3. Now 8 times 2 is 16, so I get x equals 16 times log 3 minus 27 times log 2 over 3 log 2 minus 2 log 3. And all of this is equal to 9.6548. Alright, in this video, I'm going to be solving the equation x to the power of 3 minus x squared is equal to 100. So, my only variables in this equation is x, so this is what I'm going to be solving for. And now for my solution. I'm going to rewrite my equation down here so I have a little more solving space. So I have x to the power of 3 minus x squared is equal to 100. And now I'm going to subtract 100 on both sides as my first step. So now I get x to the power of 3 minus x squared minus 100 is equal to 0. From here, I'm going to rewrite x squared, or negative x squared, as negative 5x squared plus 4x squared. And next, I'm going to write 20x minus 20x, and then I have this minus 100 is equal to 0. So the reason I did this is because 5 times 4 is equal to 20, and we want to make this factorable, so we need to have two terms that, when added, make negative 1, and when multiplied, make 20. So now from here, I can reorder this and make this equal to x to the power of 3 plus 4x squared plus 20x minus 5x squared minus 20x minus 100 equals 0. So now I can factor this much simpler. So from x to the power of 3 plus 4x squared plus 20x, I can factor out x, so I get x times x squared plus 4x plus 20. And now from negative 5x squared minus 20x minus 100, I can factor out negative 5, so I get negative 5 times x squared plus 4x plus 20, which is equal to 0. And now notice how both of these terms have x squared plus 4x plus 20 in them. So now from here, if I factor out x squared plus 4x plus 20, I get x squared plus 4x plus 20 times x minus 5 is equal to 0. And this gives me two equations. I get x squared plus 4x plus 20 is equal to 0, and x minus 5 is equal to 0. So I'm going to first start by solving x minus 5 equals 0. So to solve this, all I have to do is add 5 on both sides, and I get x is equal to 5. Now for x squared plus 4x plus 20 equals 0, I can use the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, in this case, a is 1, b is 4, and c is 20. So I can just plug these in to this formula. So now, I get x is equal to negative b, and b is 4, so negative 4 plus or minus the square root of b squared, which is 4 squared, minus 4 times a, which is 1, times c, which is 20, all over 2a, so 2 times 1. And now this is equal to negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 20, which is 80, over 2 times 1, which is 2. And now this is equal to negative 4 plus or minus the square root of negative 64 over 2. And from here, notice how we have the square root of a negative number. And most people would think that this is not possible to do, but what we can do is rewrite this as negative 4 plus or minus the square root of 64 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So if I replace the square root of negative 1 with I get x is equal to negative 4 plus or minus the square root of 64 I over 2. And the square root of 64 is equal to 8. So I get x is equal to negative 4 plus or minus 8i over 2. Negative 4 divided by 2 is negative 2, and 8 divided by 2 is 4. So these are two other solutions. Now, my three solutions to this problem are x equals 5, x is equal to negative 2 minus 4i, and x is equal to negative 2 plus 4i. So these are my three solutions to this problem.